who did the optional homework so I can give you your optional credit? Raise your hand if you completed this assignment. You did the whole thing. Math.
I would have done it if you told me about it.
Can you stop saying that?
I said it once.
No.
Yes.
Well, sort of. Don't even say anything else about it. Just him. Anybody else?
We did part of it.
No. You get the experience, which is good. Better than nothing. Anybody else do all of it? I got you. Okay.
It's too bright.
It should be good now. All right. So the question number 1 says, if the teacher announces that the p-value of his giving a quiz on any particular day is 0.2, what does that mean? It means a p-value is a probability value. That's what the p stands for. And the probability of him giving a test, if it's 0.2, that's a 20% probability. In other words, 2 out of every 10 days he would give a quiz. Or, simplifying the fraction, 1 out of every 5 days he would give a quiz. 20% chance of a quiz on any particular day. Number 2, null hypothesis asserts that any difference between two groups is a result of random chance plus natural variation. So if I am comparing boys and girls, and I want to see who has, let's see, the longest eyelashes, do you think girls actually have longer eyelashes? Because Minnie Mouse and all the other cartoon girls do. Is that a real thing? Or do you think eyelashes are really the same length between them?
Because they put that weird
Somebody
stuff
could do
on
that.
it.
It depends because
These are really long.
Right. So anyway, so let's suppose.
You think girls are like
No. Let's suppose I have a group of girls and a group of boys, and there's no difference. It's not related to gender at all. It's not a sex-linked kind of thing. But within the boys, some people have longer eyelashes and some have shorter, and some girls have longer eyelashes and some have shorter. And I randomly select between those groups. I select 5 boys and 5 girls, and I measure their eyelashes, and I find out that all the girls have longer eyelashes and all the boys have shorter eyelashes. It's possible that I could do that because there's random chance involved, and there's natural variation. Some boys have longer eyelashes, some boys have shorter ones. Some girls have longer ones, some have shorter ones. When you have natural variation, and you randomly select from groups with natural variation, it's possible that you might just happen to select all boys with longer eyelashes and all girls with shorter, even if there's no difference. So the null hypothesis always assumes that there's really not a difference, and if we do see a difference in this test, if we see an effect, it's not a real difference between the groups, it's just random chance and natural variation put together. When you get those two, you always have some chance of seeing a difference, even when there might not be an actual difference overall. Yeah.
It's a hypothesis. It doesn't make it.
Yeah, I was
Connor.
raising my hand.
Connor, it's okay.
Thank you.
Simmer down there, Connor.
So, there might be a little room for error because girls put that weird mascara-y stuff on
Right.
it.
So if we were going to design a study,
it makes it
on
stand up more.
They put that weird mascara-y stuff on there.
Everyone could put that.
They're like
Yeah, we could do that.
And then make it go like.
They make them longer.
Does it actually lengthen them or does it make them look longer?
It makes them stand up more, so they
if there's different brands
So-
of
Actually, it
different
depends on what type.
Seems like it would make them hang down if it would weight them down. Doesn't it just thicken them?
If you get high legs.
See, this is a topic. This is a topic that needs
The
investigation.
high legs makes them look really long. The volume actually makes them look really thick, but it still makes them look longer. They never like. It's
So you
not
should
like
study
they're too
this,
heavy
or somebody.
I am so confused.
I could break them in.
I picked a hot
You
topic.
could get a whole bunch of different brands and test them on
That's
color.
the story. isn't it?
I don't know. Do you have my shade?
All right. So let me move on. So
I mean, black really goes well with this.
I'm going to write a null hypothesis for this investigation. It says write a null hypothesis. I'm just going to read the alternate hypothesis. The alternate hypothesis says when people are sleep deprived, they emit more snores per hour during sleep. So that if you deprive people of sleep, their snore frequency is going to increase. That's That's the alternate hypothesis. Ordinarily, that's what people would call the hypothesis. That's what you're trying to really prove. You think, maybe this is true, and you want to set out to prove it. So what you do is you don't prove that with statistics. You set up the null hypothesis, which is this, and then you disprove that with statistics. So the null hypothesis is there's no difference between the snore frequencies of sleep-deprived people and well-rested people. So there's no difference between those two groups of people. Yes, there's natural variation in any people, but the two groups vary the same. Yeah, Matt.
If you were doing like a professional experiment, would you have like one group of people do the regular hypothesis and then another group do the null hypothesis? And see which conclusion was like.
No, it
Not
would
this-
just, so the idea of the
'Cause that's
regular
another
hypothesis
variable
and
we
null
even have.
hypothesis, it's, sometimes the null hypothesis isn't even stable. It's just, it's this concept that in order to really understand what the statistical test is showing us, it's this concept that we talk about so you'll understand.
And when-
So what we're doing here is you get data on snoring, and you're trying to prove your alternate hypothesis. And what you say is, well, look at this. Look at these people who were well rested. They snored during the last hour of their sleep. This person snored 0 times, 120, 0, 0, and 0. For people who are sleep deprived, we had somebody snoring 300 times, 250 times, 0, 0, 8, 12, 152. So what the statistical test will tell us is if there really isn't a difference between these groups, if they're really the same kind of distribution of snorers, what is the chance of finding 4 people with zeros here, a lot fewer snoring just overall, and this many, and people snoring 300 times, 250 times? Is that going to happen just by chance if there really isn't a difference between the groups? So you don't need to test 2 hypotheses separately. The null hypothesis is just a way of looking at the data. So going down to the next part, this is where the front page deviated from the back. If
Once
you
you have
compare-
once you have to test if how much they snored when they had sleep and see the difference.
Okay, so here's what was done. These are the number of individual snores emitted during the last hour of sleep during the night of January 15th through 16th. So on this one particular night, all these people were tested. Their snores were counted during the last hour of their sleep. So they had to sleep at least an hour for this to happen. And these people, 1, 2, 3, 4, 5, 6, 7 of them, they had slept 4 hours every night for the last 14 days. And these people, they had slept 8 hours per night for the last 14 days. I don't know how they made them sleep exactly that much time, but somehow somebody managed this in this fictitious, made-up, hypothetical experiment.
Knocked them out.
And so all they had to do was, during the last hour of sleep, they counted the number of snores. Seems like a pretty organized way to do it. So for the 4-hour sleepers, N equals, for the 8-hour sleepers, N stands for sample size. I don't really know why. I should look that up sometime. But
Number?
there are 7 people in this group. The people who slept 4 hours per night for the previous 14 days, there were 7 of them. And the 8-hour sleepers, there were 1, 2, 3, 4, 5. So it's a 5 by 7 test.
What's the last hour of sleep?
Oh, so if I go to sleep tonight at 9 o'clock and I wake up at 1 o'clock, the last hour of my sleep would be from 12 to 1.
So it was different for every person.
It would have, for the 8-hour sleepers, it would have been the 7 to 8 hour time period, and for the 4-hour sleepers, it would have been the 3 to 4 hour time period. What's that? And that's, I decided to make it that way because I wanted to control for, I want it to be as much the same as possible, so everybody is getting tested during the last hour. If you did number of snores over the entire sleeping period, that wouldn't be fair because these people would be sleeping twice as long than those people. You could do number of snores per hour averaged over the whole time period. That would do it too. Now, the next question is, use a rank sum table to find the critical rank sum for this experiment. Here's the rank sum table that I gave you. And let's see, does it tell you more? Yeah, it says at alpha equals 0.05. The alpha, that's the significance cutoff. We'll talk about that in a second. And for this particular test, if there's 7 people in one group and 5 in the other, this chart tells us to go across the top for the smaller sample. That's the 5-person sample, and go down here for the larger sample. In 2, that's the second group. In 1, that's the first group. And then that leads to this data right in here. Now, this is a one-sided test. It's all the tests that you're going to do, I want you to do one-sided tests. One-sided tests say, we think that these people do more than those people. A 2-sided test would be, we think that these 2 groups are different, we don't know how. This one might be bigger, that one might be bigger, but we're always going to choose sides, so it's one-sided. There's the significance cutoff, there's alpha, 0.05, so 21 is the answer. Now, and again, slow me down if you've got questions. Otherwise, you'll just have to watch this and figure it out from playing it over and over. What does the symbol alpha stand for? It's a significance cutoff. It's the level of certainty required for reporting significant findings. And 0.05 means the chance of the null hypothesis being true is 5% or less. It's got a 5% or less or lower probability, which means the chance of what we're trying to prove, the alternate hypothesis, is 95% or more. And that's a standard significance cutoff for scientific studies. Sometimes people will want alpha to be 0.01, 0.005, something like that, if you
Wait,
want
so
much higher confidence.
So if it was 0.01, it would be 99%.
Right.
And why
You'd be
is it
99% certain.
90% for 0.05?
95%.
Well, let's keep going. So right here, it doesn't really, there's nothing about 90% for 0.05. Number 8 says, suppose you calculate a p-value of 0.1 for one of your hypotheses. Suppose you did. You used this number, the rank sum, for a significance cutoff of 0.1, not for 0.05. First, would you have calculated the p-value for your alternate hypothesis or your null hypothesis? And the answer is your null hypothesis. All these p-values that you see in the tables, they apply to your null hypothesis. All these numbers, this is 90% chance of your null hypothesis being true, that's 95% chance, 97.5, and 99.5% chance. So, B, what would that p-value tell you about your alternate hypothesis? A p-value of 0.1 would tell you you're 90% confident in your alternate hypothesis. And what would it tell you about your null? There's only a 10% chance that my null hypothesis is true. So a p-value of 0.1 says there's a 10% chance of this effect happening just by chance. There's a 90% chance that there really is something going on here.
So
There really
where-
is a difference.
Where is Keegan today? Did he tell you?
Jeff, Number 9, I've already said this because you've already asked. For a typical scientific test, what is the statement, there's a significant difference between the 2 groups means?
What are you talking about?
It means the alternate hypothesis has been supported at 95% confidence, or alternatively, the null, there's a less than 5% chance of it being true. So that's what significant usually means. When people say the data are significant, they mean 95% cutoff. Sometimes they'll say the data are significant at 99% confidence. They would tell you that if they were more significant. Now, number 10 and 11, this is just performing the test. And if you use this data, or sorry, these data, my wife would be upset with me if I acted like data were singular. Data is plural. Data. The word data is plural. If you want to do singular, it's a datum.
You go back up to number 9.
Number 9? Sure.
I don't understand.
So let's say, Matt, that I do this experiment. Can I borrow yours? What's your question?
Oh.
Oh, no, wait, I don't want to reveal yours because some people will know.
Oh, yeah.
Yours is secret. Can I use yours? Okay, this is not their question, this is just a question. Do juniors and seniors carry more binders or books? Let's just do binders than sophomores and freshmen. So I do this study, I publish my results, and I say there is a significant difference in the frequency of carrying binders if you compare juniors and upperclassmen to lowerclassmen. Is it upper and lower? Okay. So there's a significant difference between the number of binders carried by upperclassmen and lowerclassmen. And by saying that, what I'm really saying is, I am 95% confident that there really is a difference. Got it?
Yeah.
Got it.
Okay. All right, now to the ranking part. For this, I used these data down here. Doesn't that sound weird, these data?
Yeah, that sounds
Yeah,
bad.
that's right, though. I'm sorry. You don't have to do it, but I'm going to do it because, again, if my wife watches this video, she's going to really, I don't know what the word would be, but she won't be happy with me.
She's gonna watch this video.
Probably not.
You should be like filmed by Connor, the
Now I might just
best.
show it to her and have her fact check me and see if I'm right. So this is supposed to be the same data set as the one on the other side, but I altered, this was the original one, the one on the first side, I altered it to make it more significant. This one, you won't actually find any significance. So if I'm using these data and I'm doing my rank sum test, what I do is these are my sleep deprived people, these are my well-rested people, and I just take their numbers and start to list them from left to right. Make a separate column for each number of snores. Go from low to high. So there were 1, 2, 3 zeros in the well-rested group, I put them there. And there were 2 zeros for the sleep-deprived people, I put them there. And then there was a 2 for the sleep-deprived people, I put it there. And then next came this 6 for the well-rested people. And then there was an 8 for the sleep-deprived people. And then a 12 for the sleep-deprived people. And then there was a 13 for the well-rested. And the next number was a 120 for the well-rested. And then I had 152, 250, and 300 for the sleep-deprived group. So the ranking is pretty easy except for dealing with all this 5-way tie for first place. But these, oh no.
Oh no.
I'm gonna stop, didn't I?
You're such.
Oh,
Oh yeah.
what did I do wrong? What was my mistake?
You made it oopsie.
These are tied for first, second, third, fourth, and fifth place.
Oh, you did
What
2.5.
would their rank be?
Not 2.5.
Wouldn't be 2.5. What do you get if you average 1, 2, 3, 4, and 5?
2.5. 3.
Okay, so what's the average of 1 and 5?
3.
3. What's the average of 2 and 4?
2.5. 2.75. I don't know.
3. What's the average of 3?
3.
3. So it's 3. If you add them all, if you add 1 plus 2 plus 3 plus 4 plus 5, add up all those places and divide by 5, you don't get 2.5. I don't know. Sorry, I was
This is science
I was
class.
out to lunch.
How'd you do
What
that?
I had, Mr. Stapleton. No, you had 1.75. Don't even lie.
So these first 5 characters here, they're tied for first, second, third, fourth, and fifth place. So we give them all a rank that's the average of those numbers. When there's a tie, you think about all the different numbers that they're tied for, and then you average that. And the average of 1, 2, 3, 4, and 5 is 3, not 2.5. I was just thinking 5. I'll take
Divide by
that in
2.
half.
That's like
But
the average.
so my sum down here, my rank sum, so what you do is you add up the group with the lower expected numbers. So the one that you expect to have lower ranking, that's the one you add up. And for these first 3 people in the well-rested group, because I don't expect the well-rested people to snore as much, that's according to my alternate hypothesis, then I do 3 plus 3 plus 3, and so instead of, in the end, 35.5, I'm going to get 37. Let me check that math there. 3 plus 3 plus 3 is 9, plus 7 is 16, 26, 36, 37. So, that's my rank sum. Up here I wrote 35.5. It's really 37 using these data down here.
I'm videotaping.
And so now my conclusion
Smile
from
hand.
all this. The critical rank sum for a 6 by 8 test. I'm sorry that my data on this page don't match my data on the other page, because on the other page it was a 5 by 7 test, but my critical rank sum for a 6 by 8 test is 31. And let me show you why that's true. Here's 6, and down here is 8. So if I come together, these are the 4 numbers for the 6 by 8 test, and 31 is my number, my critical rank sum for a p-value of 0.05. So, as a conclusion, I'm going to change this to say the rank sum for well-rested people is 37.
You look distressed.
That is greater than the critical rank sum of 31, so we are not 95% confident. These data are not significant.
These data is just annoying me.
Yeah, that's kind of annoying. Matt?
When you're trying to find your sum, do you always find the one that your alternative one is, your alternative hypothesis is supporting?
It's the one that, according to your alternative hypothesis, the one you expect to have lower ranks, that's the one you do the sum of
Oh, I
ranks.
got it, yeah.
So now let me show you, I did this again with the data on the front. So the front data were different. There was a bigger difference, and this actually does end up being significant. Remember, I've already done this. There were 7 people in this group, 5 in that one. I looked on the rank sum table. The critical rank sum was 21. And when I ranked all of these, I got this. And I screwed it up again, though. I screwed it up.
Gosh
These
dang
are tied
it.
for 1st, 2nd, 3rd, 4th, 5th, and 6th place, which wouldn't be a ranking of 3 on average. It would be what?
Whatever.
3.5.
Yeah.
That's really going to mess my sheet up, because those 3.5s are going to put me over the significance cutoff. 3.5 plus 3.5.
Why do you mess up so much, Mr. Stapleton?
I don't know. So instead of 21, I get 22.5. So my conclusion should say the rank sum for the lower expected group is 22.5.
Mr. Stapleton,
Mr. Tablespoon.
Oh, I missed one.
Gosh dang it.
Darn it, I messed up again. So it'd be 23, right? Is that right?
no.
Yeah.
So 7 plus
Yeah.
7 is 14, plus 9 is 23.
Yeah.
Riley, you messed up.
So the rank sum for the lower expected group is 23. That is greater than the critical rank sum of 21, so we are not 95% confident that sleep-deprived people snore more often during the last hour of sleep.
So is this gonna be our test?
So your quiz next class is going to be, it's going to have all the same concepts on there. The questions won't be exactly the same, but you'll need to know everything you would need to know to do this. There's definitely going to be some set of data that's not going to be screwy like this one, and yeah, if you can do all this, you can do the quiz.
Uh-oh.
Yeah, you can always retake quizzes. So will you turn the movie off?
I like this movie.
Well, turn it off. Every movie has to end.